I hope the screen is visible to you and I'm audible to you. Today we are interested for the revision of unit number 2, that is the substation and earthing. In the previous class, we have discussed the unit number 1, distribution system, and we are interested for taking the revision is whenever your exam will be there, there will be no trouble for you to write that particular exam. Yes, and we are interested for getting a good marks in the subject EIMT, and this can be your subject in which you can score above 80 marks. I'm saying with the comparison with the 100 marks. Okay, that is my you can say the wish. You all have to score above 80 marks. Yes, and I hope by taking the revision, that will be the helpful for you if those who have missed the classes particularly, so they can get the idea from this particular revision. Okay, so this is my intention to revise the unit number 2, and today we are interested for the substation part, and after that we will discuss the earthing part in detail. Okay, before that we are always looking for the previous year question papers. Let me share my screen. In that we are interested for the previous year question paper. So these question papers are already circulated in your Google Classroom. I feel that you have seen that particular question paper for the EIMT subject. Okay. So this is our point of interest. Yes. You can see over here, this is a 30 marks paper, and for the 30 marks paper, the 10 marks can be asked from unit number 2. Okay. This part we have discussed. Okay. So this is our interesting point. Question number 3 and 4 is related to the unit number 2, and they have asked explain the neutral earthing with diagram. So it carries the 5 marks. Explain with diagram single bus bar system with sectionalization. You have to draw the circuit diagram, and then you have to write the explanation, and then you are interested for the advantages and disadvantages. Okay, and the fourth question is draw any 5 symbols with their specification used in the substation. You can see this question is of 5 marks, and you have to draw the 5 symbols with their diagrams, and you have to write the specification also. You have to write the rating also. Okay. And if you are able to write the application, so that will be the you can say the wonderful thing for the examiner also. So he will obviously give you out of marks. And this is the important point. I already told you that the sure question will be asked from this particular point. They are asking explain the touch voltage and step voltage. It carries the weightage of 5 marks. Okay. This is for the unit number 2, and we will discuss the end semester exam paper also. For the end semester paper exam, here is a, you can say the question is state the objective of neutral earthing. Same way they have asked the neutral earthing objectives, and after that they have asked the only that was the question from unit number 2. Okay, so there is no question. Okay, condition monitoring is there, and various abnormal condition of induction motor pushing. Yes. That was only the question from this particular paper. Okay, so we will go for the third paper. So this is again the 70 marks paper, end semester paper, and we will see what are the questions are asked from unit number 2. Yes, so this is the question. Classify the substation, list the various equipment used in the substation with their specification. Obviously, this carries the weightage of 7 marks. You must be right in a systematic way to get these 7 marks. Okay. If you are going to draw the, you can say the tree diagram, so it will be better for you to explain the things properly. And if you can able to draw the symbol also, so it will be better also. So this is the 7 marks question. Yes. Yes. So this point today we have discussed in the morning practical. So they have asked define and explain its significance with respect to condition monitoring. So this is from unit number 3. We will revise this concept in detail also. And the next question is, yes, this is explain the pipe earthing with diagram. Again, it for 7 marks. So one can say in the end semester, it carries a weightage of 7 marks, this unit. And for in semester, obviously, you are interested for 10 marks question. Okay. So we'll start with the revision. So I hope you are getting now confidence that you can write or you can score 7 out of 7 or 10 out of 10. Okay. So we will start with our revision. So this is our interesting point. So if you are going to see this such a diagram, obviously it is nothing but the substation or it is nothing but the switch yard. So better if you are having the notebook and pen with you. So if I'm going to speak some MCQ type question, then you can able to write or you can able to make the screenshot also. Okay. So there is always question will be asked for you. What is the power system diagram? So I already explained you. Whenever we are interested for the generating station produces the voltage of 11 kilovolt. This 11 kilovolt is converted into 132 kilovolt. Obviously, we need the step-up transformer for this. So you can see the symbol of transformer. After 132 kilovolt, we need to make the step down. So that is called the 33 kilovolt. This is a step down transformer. And you can see this state or this step is called as a primary transmission. After that, we need the secondary transmission. So this 33 kilovolt is converted into 11 kilovolt. This is called as the secondary transmission. And if sometimes some substation needs this 33 kilovolt, then we can make the tapping from this, or we can make the connection for this. Again, this 11 kilovolt we cannot use directly, but no doubt in some industry this 11 kilovolt can be used. So this is called as the primary distribution. Obviously, we have to use this 11 kilovolt in an efficient way. In the industry, in the, you can say, in a big factories, we are using this 11 kilovolt as a voltage. And after 11 kilovolt, obviously we need the distribution transformer having the combination of delta to star. And this is called as a secondary distribution. So one can say primary transmission, secondary transmission, primary distribution, and secondary distribution. So these are the 4 levels of our power system. Yes. So that diagram you can able to draw at your own. Okay. Now this is our substation schematic, or you can say single line diagram. You can see over here, this is a transformer. So this is the circuit diagram you can see, or you can see the connection diagram, and this is the single line diagram. All the components are presented in a single line. That is called as a single line diagram. Yes. जर जास्त फास्ट होत असेल तर तेवढं पण मला सांगा. येस. पण मला वाटतं आहे की तुम्ही थर्ड इयर फर्स्ट सेमिस्टरला शिकत असल्यामुळे यू कॅन कोप विथ माय स्पीड. ओके. सो दिस इज अ ट्रान्सफॉर्मर. वी डोंट नो दिस कॅन बी अ स्टेप अप और स्टेप डाउन ट्रान्सफॉर्मर. वी आर नॉट बॉदरिंग अबाउट इट. After that, we need the oil circuit breaker. So oil as a medium is used inside the circuit breaker. So today morning we have discussed the air circuit breaker. So air is used as a medium. Okay. So this is the isolating switch. You can see over here. This is the bus bar. After this, we are using the isolating switch again. After again, we are using the oil circuit breaker, and we need one, you can say, the line of conductor. So this is the one can say this whole assembly forms a substation. Now, what is a substation? There is a, you can say, the conventional definition is it is an assembly of apparatus which transfers the characteristic of electrical energy from one to another. So you can say, or you can see over here, it is an assembly of apparatus, electrical apparatus, which transfers the characteristic of electrical energy from one to another. So either we need, or either we have to change the voltage, then we need the assembly. For example, or you can say from alternating current to direct current, or from direct current to alternating current. So that assembly we need, and it forms a substation. Why we need the substation? Obviously, we are bothering about the budget. So one can say for the economical transfer of electrical energy, or to meet the various demand of the load, we require the substation. So obviously there are classification of substation. So the first classification is nature of duties, and I told you one simple analogy to remember these types. Yes. So you have to remember, or you are not, you can say you are now habitual with this word, COVID. Yes. and simply you have to replace this word with DRVID. Okay, so only you have to replace this CO with your, or you can say doctor, DR. Yes, so DRVID is the classification of substation, and D stands for duties. In our analogy, we are getting the two Ds. So first D stands for duties and second D stands for the design. Okay, so according to the nature of duties, so duty is nothing but we can make the step up or step down. So one can write at their own the explanation. Obviously, whenever we are going to say step up transformer is there, then it is called as a step up substation. Yes, we need the step down substation also, so it is also called as a distribution substation. Yes, and we are using a distribution transformer here. So this is depending on the nature of duties. After that, we are interested for our service requirement. So this R stands for the requirement. Now what is the service requirement? So if we need the transformer, that can be a service. If we need the switching substation, so either for the application of on and off, we need the switching substation. So it does not change the voltage level. It only used for the operation of switch on and switch off. Okay. So this is the second subtype. The third subtype is also there. That is called the power factor correction. So obviously we need to correct our power factor, and you know that whenever we are interested to do our power factor near to unity, we have to do certain arrangement, and this arrangement is nothing but the power factor correction arrangement. Yes. So I guess from your class there can be a topic of seminar based on this. Okay. Now we are interested for the fourth subclassification, that is a frequency changer. You can see from this particular word, service requirement is there. So if you are interested to change our service like frequency, then we need the frequency changer substation. Yes, I'm not going to write, or I'm not going to read each and every line clearly. I'm just revising the things. I'm going to do the brush up for the particular concept. Okay. So if we are interested to change the frequency, then we need the frequency changer substation, and the next is nothing but the converting substation, AC to DC or DC to AC. So service requirement is there. Industrial substation is a need of a particular industry, so we need the industrial substation. Yes. So what is the third word? The third word is stands for voltage, V. So depending on the voltage, operating voltage, there the substation can be divided into three types: high voltage substation, extra high voltage substation, and ultra high voltage substation. So what is the meaning of high voltage substation? So one can say between the range of 11 kilovolt to 66 kilovolt, it is called as a high voltage substation. If we are using beyond 66 kilovolt, let's say 132 to 400 kilovolt, it is called as the extra high voltage. And beyond 400 volt, 765, or you can say nowadays there is a concept of 965. Yes, 965. So it stands under the category of ultra high voltage substation. It obviously in the quantity of AC. Yes, so we have not written over here the classification of substation on the basis of operating voltage for the AC. Yes, so one can say 11 kilovolt to 66 kilovolt high voltage, extra high voltage, and ultra high voltage. The fourth word is related to the DRVI. Now I stands for the importance. So if we are interested for the grid substation, so I told you how to remember this concept. In India, you can understood that there are 5 regions, and in that 5 regions, we are using the particular region. So let's say Western region, let's say Northern region, let's say Southern region. Yes. So these regions are nothing but your grid. Yes. So we have to connect these regions together. So I already share you that wonderful news that our India is capable of one grid, one nation, and one frequency. So all the grids, 5 grids, are connected together, and they are working now at one frequency. Can you imagine the frequency which I'm using in my institute or in my cabin is the same which you are getting in your house. Yes, so that is a wonderful concept. Yes, one nation, one grid, and one frequency. I'm not promoting that concept, but I'm awareing you about this. Okay, so this is called the grid substation, and The purpose is very important. We are interested to transfer the bulk power. That is an interesting point. If we are using the bulk power, then obviously we need a rug, or you can say the substation which can capable or which can transmit this power via you can say strong transmission line or strong conductors. So we need the grid substation. Yes. So after the grid substation, so there is a town substation is there. So near to your house or near to your town, there is a step down voltage substation is available. So this is called as a town substation. So you can remember this word with the help of importance, because if the grid substation is not available, so we cannot transfer the bulk power from one region to another region. Yes, and if there is a no availability of town substation, then you cannot get the power in your house. Okay, and the fifth point is related to the second D, that is called as a design. Okay, so how to design the substation? Depending on, you can say, indoor capability and depending on the outdoor capability. So the name indicates itself. If we are using the indoor components inside in our you can say the structure, then that is called the indoor substation. And obviously we have to install up to 11 kilovolt only. Yes, so that is a limitation, because I told you whenever we are going beyond 11 kilovolt, then there is a possibility of, you can say, the high voltage is going to occur. Yes, and this high voltage needs a clearance. Let's say this is the conductor 1 and this is the conductor 2. So we need to maintain the clearance between these two lines, because if we are keeping these lines together, then there is interference is going to happen. And how the interference is going to happen? I told you, you have to remember the right hand thumb rule. What is the right hand thumb rule? So whenever we are holding the conductor in our right hand, the thumb indicates the direction of current and the curved fingers indicates the direction of magnetic flux. So if you can imagine 11 kilovolt conductors are placed near to each other, so it will process a magnetic flux around it and it will make the interference with the neighboring transmission line. So hence this is the limitation of indoor substation. Okay. The second part is outdoor substation. So beyond 66 kilovolt, or you can say beyond 11 kilovolt, we are going to choose the outdoor substation. And obviously we can use the big components like circuit breakers, or you can say the power transformers in the industry. Okay, and the outdoor substation is categorized under the pole mounted, which is, you can say, the 4-pole structure. Yes, but the range is also you can say 11 kilovolt by 400 volt. Yes, it is not like 66 kilovolt only you are using the outdoor substation. The substation which is available at outside, that you can name this as outdoor substation. Yes, and this H pole is nothing but the letter we are using as H shape, and here we are mounting our transformer. That is our interest. So you can say this is the pole mounted substation. It can be a type of outdoor substation. The second type is the foundation mounted substation. So you can see somewhere. So we need the foundation for a particular transformer. So that can be called as a foundation mounted substation. And the capacity about 250 kVA of transformer are too heavy for pole mounting. So we have to choose for foundation mounted substation. Okay. And the last is the underground substation. Yes. So this is under the category of outdoor. It is not under the category of indoor. Why? Because see, one can say if there is a fault, then we can able to identify that fault in a quick manner. Yes. So there are, you can say, ducts are available to lay the conductors, and by opening that duct, we can identify that fault. Yes. So this point you have to remember. The underground substation is under the category of outdoor substation. Yes. Now the next point is selection and location of site of substation. So we are already interested for these 6 points. So the first point is we are interested for the type of substation. So this is the first point. We have to choose the 5 types, and based on that 5 types, we are picking our right substation. The second is availability of suitable and sufficient land. So if we are interested for the particular voltage range, then we have to use the particular area. Yes. So you have to remember in a such a way that 50, 25, 10. So you have to make the half. Same way for here also you have to make the half. 400, 220, 200, 200 kilovolt cannot be possible in electrical engineering. And after 220, obviously there is a 132. Okay. So communication facility is needed because we have to communicate between the two substations. So in the interconnected system, we have seen S1 substation here and S2 substation here. So if we are interested to communicate between these two substations, we can use the telephone or we can use the mobile phone. Yes, but make sure that the tower should be there. Yes, because if the coverage is not there, then that person cannot call with this person. So this communication facility must be there. Atmospheric condition, we have to check. Availability of essential amenities to the staff, we have to check, because the people who are working here or who are taking care of that particular substation, that the care we have to take. And the drainage facility, we have to check properly. Because see, I told you, whenever you are going to pour the water, that water sometimes make the dirt, or you can say that water sometimes make the mud. Yes, so this cannot be happen, or this is likely to be happen inside the substation. तुम्ही बघितलं असेल की सबस्टेशन मध्ये ज्यावेळेस तुम्ही जातात त्यावेळेस तुम्हाला चिखल कुठे दिसत नाही. Yes, because their drainage facility is very, you can say, perfect. So after pouring the water, there is no deposition of water in particular area. So it will go directly into the earth. That is a requirement of our earthing system. And these 6 factors we are interested for the selection and location of site of substation. Okay. So these are the various components used in the substation. I have made the list of, you can say, the 9 components, and if you are able to draw the symbol, then it is a wonderful thing for you also. The circuit diagram, the first component, the disconnecting switch is nothing but the isolator that I already cleared you. Yes. After that, we are interested for the earthing switch, power transformer, lightning arrestor, instrument transformers, CT and PT. The bus bar we need the control panel, and we need the wave trap. Okay, so we are interested for the function of this. So here I made the one interesting presentation. So you can see over here, this is the bus bar A, which denotes this component. This is the disconnector, isolator. This is the circuit breaker. This is the current transformer. This is the voltage transformer. This is the earthing switch, and this is the lightning arrestor. Now, what is the function of this particular components? Bus bar is used for making the connection or for conduction of current. So for the purpose of this, we are using the bus bar. Yes. Why we need the disconnector? Obviously, we have to make the connection and we have to make the disconnection. That we need the disconnector. What is the function of circuit breaker? It has to detect first, and then it has to make the connect, and it make to disconnect. Next is the current transformer, detect and transform the current as per the requirement. The voltage is nothing but it should detect the voltage, and it should transform the voltage. The earthing switch is used for protection and safety purpose, and the surge arrestor and lightning arrestor is used for the protection purpose. Okay, so these are the few equipments along with their symbol and along with their, you can say, the function. Now we are interested for the circuit breaker. So a circuit breaker is nothing but the name indicates itself. We are interested to break the circuit. You can see over here, this break is different, and there is one break you can have seen inside the electrical machine. BRAKE. This brake means we have to stop. Yes. So for your vehicle or for your cycle, you are applying this brake. For rotating machine or for rotating vehicle, we have to apply this brake. So this brake is different and this brake is different. So this brake difference you have to remember. Okay. And what is the purpose of this brake? We have to make the separation. That is called as this BREAK, and it is defined as the mechanical switching device capable of making, carrying, and breaking the current. It should make the current, it should carry the current, and it should break the current. Under the normal condition, it should make and carry, but for abnormal condition, it should break, make, and carry. So this is the difference. Here you can see the RYB three-phase transmission line we are using. We are using a current transformer. So the current transformer primary is connected over here. I hope your concept of current transformer is clear in the subject of EMI, electrical measurement and instrument. So under that, for the current transformer, there is a primary and secondary is available. Yes. So primary, I have to connect for one particular phase, and that connection is given to this particular, you can say, plunger. Yes. So the connection of C1 and C2 are connected from out, or you can say separated by this plunger, and this is connected to your DC source, and this is called as a tripping coil. Let's say there is a fault. We don't know that fault can be the underground fault or that fault can be the line to ground fault. Because of the fault, the current is going to flow from this particular, you can say, wire. Yes. Because of this wire, this coil is get energized and the connection will get connected to C1 and C2. We know that the circuit is complete now. The current is going to flow. Obviously, the DC current is going to flow from this DC battery. This connection is connected to this plunger. So it will drop down these two contacts. So this is called as a circuit breaker working and circuit breaker principle. Okay. So there is always question will be asked for you on what principle the circuit breaker works. So there is a principle called as electromechanical device, or it is a working on the principle of electromechanical. Yes. How it works on this principle? You can see over here, electrical quantity is getting sensed or it is getting detected by this particular CT. So this is called as electric, and mechanical separation is going to happen. So this is called as electromechanical principle follows in particular circuit breaker. Okay. So this point I have not discussed at the time of circuit breaker, but unfortunately I able to discuss this point for the today's lecture. Okay. So here you can see the fixed contact is available and the moving contact is available. We cannot use two fixed contact, so there is no point. We cannot use the two moving contacts because we need the gear arrangement then. Hence, we have to use one fixed contact and one moving contact. Yes. And here you can see if there is a fault, these two contacts start separating from each other, and there is the formation of arc. Arc is nothing but the air inside these two is get ionized. तुम्हाला कळत असेल आता आयोनाइज्ड म्हणजे काय? येस, ज्यांच्या घरामध्ये ट्यूबलाइट असेल त्यांना कळत असेल की ट्यूबलाइटचं जे वर्किंग आहे ते आयोनायझेशन इफेक्टवर काम करतं. येस, डिप्लोमाच्या मुलांना करायची माहिती असली गोष्ट की द ट्यूबलाइट वर्क्स ऑन अ प्रिन्सिपल ऑफ आयोनायझेशन इफेक्ट. The tubelight which we are using in a, you can say, few years back, not the today's tubelights, because the today's tubelights might be of LED. Yes, the tubelights which are having the choke. Yes, the winding choke. Yes, so that tubelight works on a principle of ionization effect. So this is nothing but the ionization is going to happen between these two contacts. Okay. Now after this we are interested for the classification. So I told you. Based on the application, we have to select this application. Yes. After that, you can see over here, this is the indoor type circuit breaker and this is the outdoor type circuit breaker. See, you can see the legs are there, and we need the foundation for mounting this particular outdoor type circuit breaker. Yes. And this concept we are not interested. Yes. So this concept we are interested. Classification based on air, oil, vacuum, SF6. Sulfur hexafluoride. Yes. After that, we are interested for the specification. Voltage rated is nothing but we are interested for the kilovolt, and rated standard normal current we are interested. So we can see the range of the particular voltage and particular current, and we have to follow the standard frequency in India 50 Hertz, and outside India we have to follow the 60 Hertz. And this is a capacity, braking capacity, symmetrical braking and asymmetrical braking. We are not interested for this definition. We are interested only for this point: voltage, current, and frequency. Okay. There is a next concept. There is a next, we can say, the component called as a disconnecting switch, or it is also called as the isolator. Yes. So again, it is a mechanical device to change the connections within the circuit or to isolate a circuit from power source. Normally, it is used to provide the isolation of the substation equipment such as circuit breaker, bus bar for maintenance, and also to be used for bus sectionalizing. It must only be opened and closed when current is zero. So this is the important condition. Whenever the current is zero or current is disconnected from the particular circuit, then we can operate this switch or this isolator. At load current, we cannot operate. Yes. So this can be a picture of the disconnecting switch. Here you can see the range of 600 ampere up to 600 ampere. It can interrupt or it can break. 46 kilovolt. Obviously the voltage is very high, so the current is very high. Here also 15 kilovolt and 200 ampere capacity switch you can see over here. And this is the location of disconnecting switch in the substation. So I told you after the bus bar you have to use the disconnecting switch, and then you have to use the circuit breaker, and then again you have to use the incoming, or you can say the earthing switch. Okay, so this is the perfect, you can say the assembly, or you can say the sequence of the particular disconnecting switch, circuit breaker, and earthing switch. Okay, so these are the earthing switches. So one can see over here the earthing switches are connected to earth. Yes, and these are the safety switches that ensures the transmission line is definitely grounded while repairs are being carried out. So if we are interested to make the repair arrangement, or if we are interested to do the maintenance, then we have to use the earthing switches, and first we have to make the earthing switch on, and then we have to carry out our maintenance. Okay. So here is the concept of power transformer. You can see over here the dry type power transformer is shown. Here is a liquid immersed transformer is shown. The power transformers are again divided into three types depending on their kVA range: small power, medium power, and large power. Yes, and I told you this concept as BIL, basic insulation level. Yes, for nominal system voltage, for this particular voltage level, we have to follow the basic insulation level for particular power transformer. Okay. The next component is the lightning arrestor. Obviously, we have to protect our electrical equipment. So that can be the alternator, that can be a transformer, that can be a generator. So we have to use this lightning arrestor. Yes. And here you can see this is called as a metal oxide variester type lightning arrestor, MOV type. जर तुम्हाला अशी रिंग दिसली आणि त्याच्यामध्ये असं काळं काहीतरी दिसलं तर that is called as a lightning arrestor of MOV. We are interested for the lightning arrestor on bus bar. So here you can see the lightning arrestor on bus bar is connected, and if there is a lightning is going to happen, then this lightning arrestor will capture that lightning and it will send to the ground. So here you can see the ground wire is available. Yes. Here I told you that whenever we are interested for the lightning arrestor, we are interested for the meter also. Yes, counter. So if you have visited the substation, or if you have visited the substation switchyard, then the counter is available, and by looking at counter you can understood that how much or how many lightnings are going to fall on that particular bus bar or particular lightning arrestor. Okay. So the next component is current transformer and potential transformer. The current transformer is nothing but it is a step-up transformer which step down the current to a known ratio. Yes, and I told you the example of 100 by 5 ampere. So 100 is a primary and 5 ampere is a secondary. And this factor you have to divide by 100 by 5, you will get the 20. Yes. So here you can see the picture of current transformer. Incoming is there and outgoing must be there. And for a potential transformer, there is a must only incoming available. Yes. What is the potential transformer? Potential transformer is the step down transformer which step down the voltage to a known ratio. So I told you the example is 66 kilovolt by 110 volt. Yes. After that, there is a concept of bus bar. So what is a bus bar? Bus bar is a line in which the incoming line come into and get into the instruments for further step up and step down. So it is made up with the copper or aluminium strips that conduct the electricity within the switchboard, distribution board, and substation. And we are using the bus bar for our substation. So here you can see the picture of bus bar, which is taken from the real substation. And these are made up with the thick strips of copper or aluminium. Okay. The next part is the control panel. So obviously we need the control panel inside the substation because this control panel plays an important role to control the things. So for controlling the purpose of circuit breaker, or you can say the voltage, the current, we need the control panel. Yes, and obviously this control panel is situated in the operator's room. After that, we need the wave trap in our substation. So I already told you that wave trap is used in connection with PLCC. And what is the PLCC? PLCC is nothing but power line carrier communication. So the PLCC working, or the PLCC application is used to transmit or to communicate between the two substations. So that we need the PLCC. Now, this reduces the need for a separate infra or a communication between the substation. So we are using the wave trap. And here you can see the picture of the real wave trap. And this wave trap is very important in the substation. Yes. The next point is the substation bus schemes we are interested. So here you can see there are 6 bus schemes are available. And in your syllabus, only single bus bar, sectionalized single bus bar, and double bus, double breaker scheme is available. Yes. So why we have to choose the particular bus scheme? Because of safety, because of reliability, because of economy, and because of simplicity, we need to use the different types of bus schemes. So here is a picture of single bus system. Here you can see the bus bar is available over here, and we are using the isolator. And after the isolator, we are using the circuit breaker, and after the circuit breaker, we are using the current transformer. Again, we have to, don't forget to use the isolator here. So we are not using any sectionalization inside this single bus bar. This is simple, and which is used for all the feeders, and the transformers are connected to only one single bus as shown. Okay. So what are the advantages? This is very simple, cost effective and convenient. But obviously there is a disadvantage. One but major difficulty of this type of arrangement is that maintenance of equipment of any bay is nothing but particular line, cannot be possible without interrupting the feeder or transformer connected to that particular bay. Yes. So if you are interested to do the maintenance of this particular bay, then we have to, there is no possibility of disconnector available over here. Yes. So this is a disadvantage of this particular scheme. The indoor 11 kilovolt switchboards have quite often single bus bar arrangement. So again, this can be a disadvantage of this particular single bus system. Okay. So the next is, and the question is asked from this particular bus sectionalized. Here you can see the bus bar is get sectionalized with the help of, you can say, CT and the circuit breaker. So some advantages are realized if the single bus bar is sectionalized with circuit breaker. If there are more than one incoming sources and outgoing feeders are evenly distributed on the sections as shown in the figure. Yes. So obviously there are advantages. So any of the sources is out of the system, still all the loads can be fed by switching on the sectional circuit breaker or bus coupler. And the second advantage is if one section of the bus bar system is under maintenance, part load of the substation can be fed by energizing the section of other bus. So this is the advantages. Obviously there are disadvantages also. So that disadvantage is nothing but the maintenance, or you can say the cost of this bus sectionalized is very high rather than your single bus bar system. Yes. Now we are interested for the third scheme, that is called the main and transfer bus scheme. So you can see over here, this is the main bus bar. Yes, and this main bus bar is connected with bus coupler, and after this bus coupler there is a transfer bus is available. Yes. So how to give the supply to this particular line? The incoming line is connected to this, the OR logic we are using here. Obviously we are using the isolators, here isolator, here isolator. The jumpers are used from this, and we are using the outgoing line. Yes. But if you are interested to make the connection of this main bus and transfer bus, then we have to connect this main bus system via this jumper with this disconnector, and with the help of this transfer bus. So this is the connection of main bus to the transfer bus. So if the main bus will get failure, so we can able to switch off this particular isolator, then the amount of energy is transmitted from this particular transfer bus to this side, like this, here to here and here to here. So we can flow the amount of power with the help of this transfer to main or main to transfer. Yes. So this is the application of main and transfer bus. Obviously, the advantage is the low initial cost. The any breaker can be taken out from the service and potential device may be used for the main bus for relaying. The disadvantages are one extra breaker we need. The switching is complicated when breaker is under maintenance, and failure of bus or any of the breaker results in shutdown of entire substation. Okay, so this is related to the syllabus. I'm not taking the fourth and fifth bus scheme because believe me, the question is asked based on these three schemes only. Okay, so this is for your unit number 2A. Now we will start with unit number 2B, and in a few minutes we will revise the things in a effective way. Okay, so let me share my screen again. Yes, so I hope my screen is visible to you and I'm audible to you. Okay, so here you can see the picture of the earthing conductor. So I told you that we are using the earthing for particular transmission tower or for particular, you can say, the steel tower. The earthing is very important. Yes, so I have taken this picture for that reference. Now there is a difference between ground and neutral. So I told you that neutral is used for making the circuit complete. But if we are interested for the ground, so ground can be also called as earth. And what is the importance of this ground and earth is a main electrical wiring system is a conductor that provides a low impedance part to the earth to prevent hazardous voltages from appearing on the equipment. So that is called the ground. Now here you can see the difference between grounding and earthing. What is the difference between grounding and earthing? So you have to remember in this way. In the USA, the grounding word is used, and in the UK, the earthing word is used. And the main difference is what? In the earthing, connecting the dead parts. It means the part which does not carry the current under normal condition. So this is called as earthing. So you can remember that inside or for your fridge, there is a green wire is connected to that particular body of that fridge. So that is nothing but the earthing. Okay, and what is the meaning of grounding? Grounding means connecting the live parts. It means the part which carries the current under normal condition to the earth. So for the grounding purpose, we are connecting that grounding for our live parts. तुम्हाला आठवत असेल की तुमच्या घरामध्ये जो 3 पिनचा बोर्ड असतो ना त्याच्यामध्ये ग्राउंड टर्मिनल असतं. Yes. Now here you can see the neutral and ground we can use together. Yes, and this is also the difference. Grounding is used for protection of equipment and earth is used for safety of human body in the fault condition. Okay, so I have shown you this picture, and in this picture there are three conditions: neutral, ground and earth is available. So here RYB 3-phase or you can say 4-wire system is available. So neutral you can identify to complete the circuit, and or you can say interconnection of this star point forms a neutral. Yes, if we are interested to run our single phase motor, then obviously we need the 1-phase wire and 1 neutral wire. So this is the neutral and phase wire application. To protect for our personal or human operator, we have to make one earthing arrangement, and here you can see over here we are using the green wire to make the body of this particular machine to earth, and here you can see the ground wire is connected for the particular transmission tower. So this is the transmission tower and this is called the lattice structure. Okay, now the next question is, grounding acts as neutral, but the neutral cannot act as ground. So I told you that we can use grounding as neutral. Yes, sometimes if there is a fault, for particular, you can say yes. So here you can see grounding can act as a neutral, but neutral cannot act as ground, so that you have to remember. And sometimes if our neutral fails, or if neutral is not working properly, then we can transfer that connection to ground. Okay, it means that the grounding, or you can say the earthing, is a very important. Yes. So all the people living or working in the residential, commercial and industrial installation, particularly the operators and personnel who are in close with operation and contact with the electrical system and machineries, should essentially be protected against the possible electrification. Okay, so to achieve this protection, earthing system of an electric installation is defined, designed and installed according to the standard requirement. So what is the purpose of earthing? So the purpose of earthing is to used to make the protection purpose. Yes, and how to make the earthing? With the help of low resistance wire. That is called as the electrical earthing. The importance or necessity of earthing, this question is also asked, and you have to explain this earthing importance. It protects the personnel from short circuit current. It protects the building machineries and appliances under the fault condition. It provides the easiest path to the flow of short circuit current, and it protects the apparatus and personnel from the high voltage surges and lightning discharge. What are the types of earthing? Yes, so here is a question, neutral earthing. So I told you, neutral earthing question is surely asked. Explain the neutral earthing. Neutral earthing is also called as system earthing. So in some books they are using word as a system earthing. So what is the neutral earthing? The neutral of the system is directly connected to the earth by the help of GI wire. मला मी कसं सांगितलं की न्यूट्रल जे असतं ना आपल्या सिस्टम मधलं, we can connect that neutral directly to the earth because ground can be act as a neutral. Yes. Such a type of earthing is mostly provided to the system which has a star winding. Yes. For example, the neutral earthing is provided in a generator, transformer and motor. What is the equipment earthing? Obviously, we need to protect our equipment. So the earthing is provided to the electrical equipment. So we are using the green wire. So that is nothing but the equipment earthing. What are the methods? Conventional methods and maintenance-free method. And I told you that the conventional methods carries maintenance. Yes. So we have to dig a large pit and we have to feed the GI pipe or copper plate is positioned between the middle layers of charcoal and salt. It requires the maintenance. It requires the pouring of water at regular interval. So this is the conventional earthing you can see, and this is nothing but the maintenance-free earthing. Obviously, it is a ready-made, standardized, and scientifically developed. It is a maintenance-free. Consistency is more surface area can be captured, and the low resistance is available. The no corrosion not possible. Long life and easy installation. After that, we are interested for the understanding of earthing. So here you can see the picture of electrical system without earthing. So here the earthing is not connected, and here the earthing is connected. So if the earthing is connected, if there is a fault, that fault current is going to go from that particular earth. But if the fault, or you can say the connection is not made, so it will enter from the person's body and person will get suffered. Okay. So this is the main interest of the earthing. Why we have to make the earthing? Okay. What are the methods? Plate earthing is there, pipe earthing is there, rod earthing is there, earthing through the waterman, and strip or wire earthing. And in our practical, we have discussed these three methods. Okay. So we are interested for the earthing electrode. So this is nothing but the earthing electrode is available. The number 1 indicates the earth wire, which has a low resistance. The number 2 indicates the connector, and number 3 indicates the electrode. Okay. After that, this is the, you can say, the real picture of the earthing electrode, and this is the connector. We have to connect this earth wire to this connector so that the amount of current is transferred from this to this in that way. Now, what is the meaning of pipe earthing? We have to use the pipe as a electrode, obviously, and there is a dimension is available. Length and diameter is placed vertically in the wet soil. So we have to use the dimension of the pipe as 40 millimeter in diameter and 2.75 meter in length. So that is important. Here you can see in the summer season, to have an effective earthing, 3 to 4 bucket of water is to put through the funnel for better continuity of earthing. So here we have to put the funnel and we have to pour the water inside this. Okay, so I'm not expecting to draw this diagram, but you can draw like such a picture or such a in a short in a sketch you can draw, and you can write the explanation. This is the plate earthing. Obviously we need the perfect dimension, because see, if you are not writing the perfect dimension, then your impression will be not there. So you have to write the perfect dimension, like for the copper plate we are using the 60 centimeter by 60 centimeter by 3.18 millimeter. Yes, or you can write in the foot also, or we can use the galvanized iron dimensions as 60 centimeter by 60 centimeter by 6.35 millimeter. Okay, and this is the plate earthing explanation, and we are using the plate over here. So you can see over here we are using the plate. Obviously we need the funnel also to drop or to pour the water. The next point is the ground resistance, and today morning only we have discussed this measurement of earth resistance, and we have to maintain this as a low as 5 ohm. Okay, and why we have to use this measurement? Because we have to reduce the risk of electrical shock. So this is the method: the earth electrode, inner stake and outer stake. Yes. So we are not using the earth tester here. We are using measure directly. So this is the value of maximum for earth resistance for large power station. So you can take the screenshot also for this particular slide, because the question is surely asked. If your exam is of the kind online, then there is a sure question will be asked in particular value of resistance and particular equipment. Yes, so in a 2 second you can take the screenshot of this, and daily you have to see this screenshot so that you can remember easily. There is no point sorry, you can remember in a such a way that 0.5, 1, 2, 1, 3, 0.5. Yes, or you can rearrange these terms in a such a way that 0.5, 0.5, 1, 1, 2, 3, so that you can remember easily. Yes, large, small, but I have made in such a way that large, major, small, factories, lattice, steel and industrial machine. You have to take your own decision how to remember this table, but you have to remember this table in anyhow. Okay. Applications of earthing are telecommunication, transmission, substations and power generators. We are using the earthing. We are using the earthing for lightning arrestor equipment, body, water treatment plants, heavy industries, colleges, hospitals, banks and residential buildings. So what are the functions? Functions we are using for computer earth, telecom earth, lightning earth and equipment earth. So this is the interesting point. Our interesting point starts from here, and the question is surely asked for 7 marks. Explain the step potential and touch potential. So I'm going to explaining you the step potential first. So you have to draw the diagram in such a way that RYB, which carries the 11 kilovolt, if the conductor broke in a such a way, it will carry or it will land on the earth. It will develop its potential gradient around 8 of the value of 10 kilovolt to 9 kilovolt. After that 8 kilovolt to 7 kilovolt. After its periphery, the voltage range can be of 5 kilovolt. If the person is there who is seeing in his mobile and he is get contacted with that particular conductor, then one feet can be of in the range of 2 kilovolt. The second feet can be in the range of 1 kilovolt. Because of the potential difference between the 2 feet, he may get the shock and he may get fell down. Okay, so it means the step potential is the potential difference between the feet of a person standing on the floor of the substation with 0.5 meter spacing between the one step during the flow of fault current through the ground system. So this definition you have to write. What is the difference or what is the spacing between the 2 steps? 0.5 meter. So if we are interested for the touch potential now, so you have to remember or you have to visualize this diagram in front of you, and then you can write. There is a, let's say there is a under construction work is going on, and this is here there is a power cable is available, and this JCB is digging some, you can say maintenance work. Yes, that person doesn't know that there is a cable, so by accidentally he touches that particular cable. Then what happens? Because of that conductor breaks, the current transfers from that particular, you can say the hand for that particular machine to the persons, or you can say the body of that particular JCB. The person who is inside, he might get shock if he is not wear the gloves and he has not wear the shoes, rubber shoes. Yes, but if he is wearing the shoes, he will not get the shock, or he is wearing the you can say the gloves, he will not get the shock. But this person is not wearing the gloves, so you can see, and if the person touches, he will get the shock, and all the current or all the charges are get transferred from this person's body to the earth, and he might get suffered. So this is called as the touch potential. There is a potential difference between the fingers of a raising hand touching the faulted structure and the feet of the person standing on the substation floor. The person should not get a shock even if the ground structure is carrying the fault current. That is, the touch potential should be very small. Yes, and this is nothing but the touch potential. So hence they have measured or they have mentioned the electric wire danger, high voltage असं ते कवटी ब्युटी असते, हाडकं वगैरे लावलेलं असतात, असं सिम्बॉल असतो त्या पर्टिक्युलर ट्रान्समिशन टावरच्या स्टार्टिंगला. Yes, this is nothing but the concept of step potential, and you can say the touch potential. If the faulted structure is there, and if that faulted structure, the person is get contacted 0.5 meter distance, so he will get the shock. And if the faulted structure is there and the current is available, so if the person touches that faulted structure, so you can see this can be a tower, so he will get the shock. And we have to mitigate the step and touch potential. So this is the last point of our today's revision. How to mitigate the step and touch potential? We have to obviously reduce the resistance to ground of the grounded system. Yes. So here I have given the example. If I am using the 5000 ampere as a current and the resistance to ground or tower footing resistance is 10 ohm, then there is a possibility of step voltage can be of 50,000 volt. But if we can minimize this, the resistance, earth resistance to the 5 ohm, so we are not bothering about the current. So current can be of 7,000. So the voltage developed in between the two steps can be of 35,000. No doubt, 35,000 is a very high voltage. Yes, then and then only the person will get shocked. But because of this example, you can mitigate or you can minimize the step potential. Yes. So the conclusion is what? Reducing the resistance to the ground can leave the effect of allowing the more current to flow into the earth wire. And the second is proper placement of ground conductors. So this is nothing but the revision of your second unit. If you are facing any doubt related to this unit, then you can contact me at any time. I will try to answer on the WhatsApp. Yes, or you can drop me the mail also. Okay. So if you have understood the today's revision, then you can write the yes in the chat box. If you have not understood any single point, then you can write the